Hello students, good morning. The next important question from Laws of Motion, chapter 5. You may ask me that, madam, you are saying all questions are important. Actually, if not one other question, maximum regularly he will repeat in the question papers. So better not to take chance. Maximum he will concentrate on advantages, disadvantages of friction, reduction of friction. Okay, now limiting the explain the terms limiting dynamic rolling friction and land roller. Maximum on these 4 questions. Sometimes if he don't want to ask the regular questions asked in the papers, then he may ask such questions like define the terms momentum and impulse, state and explain the law of conservation of linear momentum with examples. This question, state the laws of rolling friction, and another a stone of a certain mass, find the magnitude and in which direction it moves. When the question paper will not have a regular way of asking questions, these 3 questions you may see. So don't take risk, easy questions, so try to prepare each and every question. Now let's move to our terms momentum, impulse. Okay, so momentum, what is momentum? Product of mass and velocity, mv. What is impulse? Sorry, spelling mistake is there, just correct it, impulse. So the product of force and time that produces the finite change, not infinite, finite change in momentum. That is force into time duration. Force means m into a as per Newton's second law. Time you denote with t, so mat. Now what is acceleration? Okay, what is acceleration? Here I wrote v minus u by t, right? So acceleration means how we will write? The change in velocity. Change in velocity means final velocity minus initial velocity divided by time. Final velocity minus initial velocity divided by time. Initial time assume as 0, final time t, then v minus u by t minus 0, t minus 0 t. So that we substituted here, you see, I equal to m v minus u by t into already one t is in the above equation. Now you write that. Now t cancels. So what remained? M v minus u, t cancelled. So now multiply it, mv minus mu. Right? What we said? This impulse you just correct. Spelling mistake is there, impulse. What I said? Impulse is the product of force and time that produces finite change in momentum. So this is the change in momentum, no? mv minus mu. Right? Now next, law of conservation of linear momentum. What he is saying, when external force is equal to 0 or when no external force acts on the body or system, the total linear momentum remains conserved or constant. The total momentum of isolated system of interacting particles remain constant if there is no resultant external force acting on it. Explanation. Here let us consider 2 non-rotating spheres of masses m1, m2. Initial velocity be u1 and u2. Right? Initial velocity be u1 and u2. Okay. So one body mass m1, other body mass m2. Initial velocity for this u1, for this u2. Before collision, what will be the momentum? m1 u1 for this body, m2 u2 for this body, and sum of momentum m1 u1 plus m2 u2. Now after collision, elastic collision, so m1 m2, their velocities changes, masses remain same, elastic collision, so velocities become v1 v2. This is after collision. So the momentum of this body m1 v1 and momentum of this body mass into velocity m2 v2. So sum of the momentum m1 v1 plus m2 v2. So now momentum of system before collision will be equal to momentum of system after collision, that is m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2, which shows the linear momentum remains conserved. Okay. Now next, the examples: motion of rocket, bullet gun motion. Thank you for watching my video. If you like it, share it, subscribe it.